Now we're going to get a formula out of the acceleration. So how do you figure out acceleration? Well, this right here is a total displacement, like we said in one of the last videos. Is total displacement of what though? It's total displacement of velocity. So a velocity equals so this is acceleration graph. Acceleration on the x-axis, the y-axis, times time, plus the v naught. If v naught is just there, if it started off at a velocity. So basically, using the graph, we get acceleration times time plus v naught. Now let's interpret a different graph. Let's go back to velocity. Let's go back to a non-constant velocity. So let's figure this out. So how do you figure this out? Well, this is pretty easy. With this, we know that, look, so basically, we use this graph right here. We can figure out the total displacement of position easily. So, because this is position right here now, and this is time. So meters per second, you get a velocity graph. So, with this, you're basically getting, so let's look. You get right here 1/2, because the triangle is on the area of the triangle, 1/2 base times height. Okay, so we know that. So we know that delta x right here is 1/2 base times height. And with that, we can also figure out so the formula actually all together, because this is velocity and this is position. So you get 1/2 base 1/2 times the x, which is the acceleration, because that's the slope, times the time. Well, that's not actually meters squared because it's acceleration times squared. So, but let's say this actually didn't start at 1. What would happen there? Let's figure that out right now. So let me quickly add some more numbers. 6. So how do you figure this out? Well, you make a line here, and it's just basically velocity times time. So the formula we get out of this is the total displacement, which delta x equals velocity v naught times time plus 1/2 the acceleration times time squared. Remember, delta x is x final minus x naught. And that is how you interpret graphs and get equations out of them.